All right, we live. Nice day, Monday. Let's go. Best day of the week. Monday. Monday, fun day. Fun day, Monday. Yeah, I'm gonna go through some. I'm studying recommender systems right now, and I need to get up to speed. And hopefully, we'll do as with the Lightning series that I will be uploading this week. That hopefully I learn enough so that I can bring some valuable, concise tutorials later on recommender systems. But right now I suck, so we need to get up to speed on how it works. And for that, I found some, tried to look at some resources, what had the most citations and so on. And this book from 2016, so it's not most updated, but it brings the most, I think the most valuable sort of concepts. And then we'll go through some papers. I mean, obviously, we're not going to be able to do all of that today, but yeah, that's the idea. And I don't know if actually anyone's going to join at this time because it's Monday and it's morning, but we'll see. Yeah, so let's go. Like, I haven't looked at any of this. This is just sort of my my thoughts right now. Let's see if we can go to this. And basically, this is the best book I've found so far on recommender systems. So we will just sort of in the last stream, we looked at neural collaborative filtering and we even implemented it. But I think there's a lot of concepts missing and I want to get a better overview of it. So I thought this book would be good to go through, get up to speed, and then look at sort of state-of-the-art papers for like graph neural networks and maybe like an overview paper of deep learning approaches. But before I do, let's just check that everything is working. Oh, there are people watching, but nobody's in the chat, or yeah, there's something wrong with this chat. All right, to pop out chat on this. Yo, guys. Good morning. I don't know what time it is for you, but here it's morning. Yeah, I don't know how long of the delay it is. I set it to low delay so that or low latency, so it should be relatively quick. Recommenders in YouTube algorithm. Just recommender systems in general. Yeah, your help was valuable last stream. All right, I'll put it over here. So like, I'll tell you like the goal, or yeah, so like the overall goal is, so this week I'll be making or uploading the Lightning series And then like now I need to learn about recommender systems for a consulting job I'm doing. So I need to get, I mean, it's a good area to know about as well. So um, I will try to get up to speed on recommender systems, look at this book, and then after I get like an actual good understanding of recommender systems and I feel like I can provide some value, I'll try to come up with some type of series where we sort of go through recommender systems. Right now, obviously, that's in the future because I need to learn it myself first. I can't teach something that I don't know, but that's the idea. So similarly, as for the Lightning series, I made streams about PyTorch Lightning, and then I made a series. I was thinking we could do the same for this. So here you get to see all the mistakes I make, and actually realize that I'm not as good as you think I am. When you see like the refined tutorials, then you might get that impression, but I actually don't know. I'm total beginner at this. So I'll learn about it now, and then that's the goal. Please do lives at the previous time. Previous time? What do you mean? I agree with the please, yeah, right. So like when I actually get to if I get to some kind of a structured stream, then I'll try to announce it. I'm still playing around with the times. I don't know which time is best for streaming and so on. No playlist will be only for sponsors. I'll upload everything, but if I've sort of created it, like for the Lightning series, I'll do I will upload once a week, and maybe if it's complete, then the members, YouTube members, can watch it directly. But it will sort of might be a time delay for others to watch it. All right, but let's I'll check at the poll, and I can do that. All right, but let's get into it. So this is the book I found. It has the most citations for recommender systems. It's a bit outdated, from 2016. Let's see, this is the book, Recommender Systems, the textbook, just the textbook. But yeah, so I think this one should be good to at least learn the concept. And let's see, so introduction, goals of recommender systems, the spectrum, basic models, collaborative filtering, content-based. So these are the basic ones that we looked at last time. Like collaborative filtering requires you to have ratings from the users, and then you can implicitly learn some type of embedding for each item and user. Content-based is more that the actual, some type of, for movies, for example, someone has sat down and rated the movie and said, yeah, this is an action movie, this is this, and created features. And from the created features, then we can learn it. It seems to me that collaborative filtering is a better approach if you have data, but content might be if you have less data or you have features already. Knowledge-based recommender systems, I don't know what that is. That's, I guess, we'll learn about. Demographic recommender systems, hybrid. And then also evaluation, right? This is a big thing I need to learn about as well. What are the metrics? I guess you would use some type of precision, or like you would look at the top recommendations and then you would evaluate it in some way. Yeah, but we'll see. Maybe, I mean, you could use like, what was it, RMSE or something as well. Some people on Kaggle use that, I think. Domain specific, context based, time sensitive, recommender location based. So I mean, you have all of these like specific cases, and so the idea is to get an overview of that. And then the cold start problem, and that's just chapter 1. All right, so we have the neighborhood based collaborative filtering. I don't know what that is actually. Item-based neighborhood models. All right, and then model-based decision trees. I I wonder if he introduces neural networks here. But then matrix factorization. And then he goes into content based. All right, so I guess chapter 1 is just more of an overview. I'll put the chat over here. Content-based, knowledge-based, ensemble-based. All right. And then here, okay, evaluate and recommender system. This is obviously a good thing. I think like one thing I was considering as well for the for one of the problems I'm facing is that if you're doing an approach for solving the cold start problem and then you don't have ratings so that you can actually evaluate your recommender system, how do you know that the solution you've come up to the cold start problem is actually a good one? And that's one question I have as well. I was thinking maybe you could look at the robustness of recommendations so that if you change the input in some way, then you'll still get stable, or you'll modify the recommendations. That might be a way. So that basically doesn't recommend the same all the time, independent of input. But all right, so here he says evaluation paradigms, accuracy, coverage, all right, novelty, diversity, because these are all you want to have to know about as well. And then you're measuring the accuracy of ratings predictions, RMSE versus MAE. All right, that's cool. That might be interesting to know about. I'll definitely not be going through all of these. Like, I won't be going through the entire book, I don't think, because it'll be just a lot of things, but it might be a good reference and to get an introduction. But then I looked at sort of 2 papers. Oh, this is, let's see, let's open this in Drawboard. By the way, this is the I like this PDF editor, or for papers and stuff. Like, you can, I don't know, do these kinds of things. And now I'm still getting used to it because I used it on Windows before and it's a little bit different here. But you can do, wait. Yeah, this one is the one I'm looking for. So you can basically do this. And then if you have another color, I usually have like yellow, orange. No? Okay. And then you can add another one, text highlight. You can modify it. We can have red for things we don't understand. And then, let's see, can I move that? I think this is an updated version. You used to be able to move these. Come on. All right. All right. All right. Let's just keep it like that then. Whatever. We'll have text highlight and a green one. Green. There we go. All right, so this is the other paper I was going to look at. This is a deep learning based recommender system, a survey. So it goes through sort of the most popular I guess, approaches. And yeah, this might be interesting as well because it's deep learning based, so it's definitely not covered that much in the book, since the book is from 2016. And so yeah, anyways, just giving you a view of my thoughts right now. All right, let's go to the book. So this is kind of interesting. Like if you look at the number of papers that are published in recommender system, I think it's like 2% of the total number of papers. I mean, like I think the most popular is computer vision, and then NLP, and then like a relatively very low percentage is in recommender systems. But if you look at the compute time, I think it was for Facebook, I think like 60% of their machine learning is recommender system based, like the computation. And if you look at the value, so the value that's brought in for these companies, then recommender system brings in the most amount of revenue. So there's kind of a large discrepancy between industry and the sort of research based. I mean, I guess it kind of makes sense because recommender system is basically like recommend this product, and if you click it, then they make money. And that's kind of I mean, it's not that exciting, right? But recommender system can obviously be used for many things, and it doesn't have to be only for ads, even though that brings in the most value. I just think that's an interesting point. That's a funny joke. Why did the recommendation system go to therapy? Because it was having trouble making decision on its own. Love it. The chapters of this book can be organized into 3 categories: algorithms and evaluation. These chapters discuss the fundamental algorithms, collaborative filtering. That's what we want to get into as well. I think that will be the most important. So chapters 2 and 4, some content-based and knowledge-based, and evaluation is obviously important. And these might be good for reference if we might be just know to have an overview of in specific domains and context. would want to use the relocation as additional context. Okay, wait. So, I mean, we basically, let's see, the basic idea is to utilize these various sources. Let's see. To infer customer interest. So we have user, we have product as item. I mean, that makes sense. A notable exception is the case of knowledge-based recommender systems, in which the recommendations are suggested on the basis of a user-specified requirement rather than the past history. Okay. I guess we'll learn more about that as well. And maybe once we learn, once we learn new stuff, then we can incorporate it into our we can incorporate into our recommender system that we built. All of this is built on Stream, by the way. I haven't done anything beside it. So here we did just a simple, I don't know what, movie lens data set. We took a small part of it and then just did the neural collaborative filtering. So this is, wait, what happened now? Let's see. And then we wrote down some next steps, but we will try to expand on this, and maybe it will maybe we'll get what exactly we want to do. Tmux. Okay, this is interesting. All right, so what is he saying? He's saying if we have more data, it makes it easier to make predictions. Many different learning models can be used. All right, so for example, the collective buying or rating behavior can be leveraged to create cohorts of similar users that are interested in similar products. I mean, that's basically the fundamental idea, right? That users like similar things, or if they like similar things, they are likely to like similar things in the future as well. And so this is the interesting part, I guess. So we have neighborhood models, because that's what I was confused about, what he refers to as neighborhood models. But then he says belongs to a broader class of models referred to as collaborative filtering. So I guess neighborhood models are a subset of collaborative filtering. And then collaborative filtering refers to the use of ratings from multiple users in a collaborative way to predict missing ratings. So basically we have a matrix and we have users on as the rows and the ratings as the columns, and we have a lot of missing values. So depending on the data set, we might have increasing sparsity or and so on, and then we want to predict what those missing values are. A different framework is that of knowledge-based systems in which users interactively specify their interest. I think this is difficult, right? Because like if I'm going to specify what I'm interested in, what type of movies I'm interested in, I actually don't know. I just like the movie, I want them to figure it out what I like. It's not that I want, because I think self-awareness is quite low, right? So we don't know exactly what we like. We just like it. But he has not mentioned content-based. All right, so we have two ways. One in which we actually predict the exact rating a user would give a particular movie, or the ranking where we recommend a couple of movies, but the absolute value might be wrong. So we just care if the ranked one recommended movie we predict for that user is actually a movie they would like. I wonder how you do for test data for this. I guess you would just remove like a few of each of every user's movie, but then if you recommend top 10, you might only have actual data for one of them or two of them. Because you want to have, like, you need to learn about the user, so you can't just, for test data, you can't just remove 20% of the users, because then information is lost. So I feel like testing in recommender system is much more difficult than testing an image classifier or something. So a recommender system has to have relevance, novelty, but serendipity. A related notion is that of serendipity, wherein the items recommended are somewhat unexpected, and therefore there is a modest element of lucky discovery, as opposed to obvious recommendations. Serendipity is different from novelty in that the recommendations are truly surprising to the user rather than simply something they did not know about before. And then we have diversity. I mean, that makes sense. Group lens. I guess that's the one that had the movie lens dataset, maybe? So these are just examples, I guess. We want to learn about the model. because I mean, like in many cases, I guess you want to have a hybrid because you might have additional information about the user. For example, you might know their age. You might, I mean, these are all things that the model can itself figure out. I guess maybe, or that it's not that important if we have enough data on what their actual ratings are. But I'm thinking it might be good to, in many cases, use a hybrid approach where you have features that might not be so easily found by the network, and then so you just concatenate the information based on both. Okay, so these are two terms I want to understand because I've heard, but I don't know exactly what they are. So there are two types of methods that are commonly used. Let's see. There are two types of methods that are commonly used in collaborative filtering, which are referred to as memory-based and model-based methods. Okay, so if we first go into memory-based, or also referred to memory-based methods, also referred to as neighborhood-based collaborative filtering algorithms. So for those, hello, TikTok, tick. We have user-based collaborative filtering. In this case, the ratings provided by like-minded user-based collaborative filtering. Okay, so in user-based, we find what other users are similar to this user, and we recommend ratings for unobserved of A by computing weighted averages of the ratings of this peer group. Okay, so that's user-based collaborative filtering, where the idea is to find which users are similar, that have similar taste in movies. Or we have item-based collaborative filtering in order to make the rating predictions for target item B by user A. The first step is to determine a set S of items that are most similar to target item B. The first step is to determine a set items that are most similar to target item B. Let's see. Okay, so we find the items that are actually similar to the movies that he's liked. Okay. Let's see. Anai says memory-based collaborative filtering is based on the user item interaction history and calculates similarity between users or items to make recommendations. Model-based collaborative filtering, I guess that's what he goes into here, uses machine learning algorithms to learn the underlying patterns in the user item interaction matrix and make recommendations. But how do we know which ones are similar? So if we have a user-based collaborative filtering, for example, we have a user, and I guess we have some type of embedding space for that user. Or I guess I don't really see the difference between memory-based and model-based. Let's see, maybe we can understand it. Model-based. In model-based methods, machine learning and data mining methods are used. Okay, so if we use anything that has some sort of understanding of each user, then that would be a model based. So if we use a neural network, that would be model based, as we get some sort of latent space for each user. But memory based is you sort of have the vector of all of the ratings, and then you do a cosine similarity or something, and you just get which users are the same, and then you take the unrated of another user that is similar, and you just take an average weighting of their average ratings. So yeah, the advantage here is easy creation, but disadvantage is performance reduces when data is sparse. And I mean, we don't really have any, I mean, we're not really learning anything here, but I guess it's very simple. And memory-based CF stores the entire user item interaction matrix in memory. All right, okay. Memory CF cannot handle new users. Is that true? I guess any system can't handle new users until we get some type of data from them, right? Because we have no idea where to categorize them. But it seems like we can just add a new row in our matrix. No? All right, let's see. So we have, thanks for the donation, by the way. One thing as well is that the ratings of each user might be different, where you might have some users who are really optimistic and some who are more pessimistic. Like some people you ask and they're like, yeah, this movie is amazing or was amazing, and some people their scale is that everything is okay. So if somebody says like, yeah, this movie is okay, then you have to sort of translate their relative scaling of stuff so that it might be actually amazing in your world, or vice versa. So that might be a problem with the recommender system as well, in that we might have some users, we might have to normalize their ratings in some way, based on their average rating, perhaps. I'm not really following what he is talking about here. Types of rating. This is we're looking at recommender system, the textbook, which has I think most amount of citations for recommender systems, and to get an overview of different concepts. And then we are going to look at sort of a deep learning based papers, maybe an overview of approaches, and we'll try to incorporate things that we learn into our current implementation that we did last stream on very simple neural collaborative filtering. But we want to introduce sort of how to evaluate our model and how we split into training and test. Maybe we want to update our model. I would really like to get into graph neural network approaches, because I think that would be awesome to learn about as well. So those are sort of my ideas right now, but we need to get an idea of the field at first. We need to know what concepts are common, how these models work, and then maybe do some simple implementations, because yeah, I mean, first of all, I need to learn it because I'm going to be making a project in recommender system, so I need to get up to speed. But as with all the things that I've made on my YouTube channel, I have sort of learned about something for a reason. Maybe I was interested in it, or I had to learn it for a project, whatever, maybe for some school project, maybe for some work related stuff. And then I've tried my best to condense and make it efficient for other people to learn it. And that is what I'm trying to do with these streams, is that you see me struggle with material, and then you are going to sort of like you can watch it live and ask questions and stuff and chat, and you can learn it together with me. And then I'll make these more efficient, to the point videos where you can learn something more like a lot easier. So that's the idea for this stream, and also for the next sort of series that we're gonna do. That's my idea right now, at least, that it's going to be on recommender systems and sort of introduce the area and then go deeper and deeper on the subtopics of it. Like what, for example, now this is based on my limited information, but I'm thinking how do collaborative filtering work? How does content-based work? What is knowledge-based? How do we evaluate these things? What are the metrics for that? How do we implement them? What are the most common models? How do they perform? Like simple matrix factorization with singular value decomposition. And then we might have other models as well. We might have deep learning based. How does these memory based methods compare to what was it, model based methods? And like the entire field of it, and then maybe build some type of project. That would be cool, and it would be awesome to actually deploy it as well. That would be sort of the best case scenario, where we build a project on it and then that can be used for something. Maybe we build like a movie recommender system that we can have, but I feel like Netflix is kind of limited in that it only recommends the movies that are on Netflix. But you could build a global recommender system based on all movies for people that I guess download stuff, and so that could be interesting. That also is open source, and that you actually trust the system, and it's not made to earn money. It's just to recommend good movies. Yeah, any tier unlocks the membership only videos, but they will not be membership only for very long. It's like no playlist will be members only. I'm gonna upload the first Lightning video this week, and then I'm thinking of doing one upload a week. So if you want access to it, like the playlist directly, then you can become a member, but otherwise it will be uploaded. For sure, yeah. I was looking at videos on trying to see if anybody has done it, but I feel like there's a lot missing on recommender system, and that's why I'm thinking it might be useful that we do it, so that when I learn it, we build concise videos that can help people learn it faster. And I feel like even if like the ones that I've seen, they are mostly like concepts based or in the idea space, which is good, but I feel like my channel is also to show how we actually build stuff, because that's what's most important, right? I mean, if you can understand the theory, but if you don't know how to transfer it to code and how it actually looks like, then to me you haven't really grasped the material, or like you might have, but on a theory side of things. So for me, it's really important, and that's when I feel like I learn the most, by actually, uh, doing it and implementing it myself. But then, sort of the end goal, right, is to make it useful for other people, not only in showing how to do it, but build products or services that people can use. And that's one thing my channel has been lacking, in knowledge that I'm lacking as well now, that I want to learn about, sort of ML ops and how to deploy things. And that's something that I'm excited about, which might be future project or future series maybe. But yeah, now it's just focus on recommender systems. All right, let's just skip a little bit, because I don't know if this is that important. It's like different types of ratings. You might have 1 to 5, or you might have 0, 1. But this is a good sort of, like, if you are creating a recommender system from scratch and you are going to ask users what is the best rating scheme you want to have, because you might ask a simple question like, do you like this, yes or no, or was this good, yes or no, but then you are missing the information on exactly how good it was, right? And if you're missing that, can you still build a good recommender system, or is it a good idea to have this 1 to 5 ratings? Because you might, like, more people might rate it if you are just saying, do you like this, yes or no. If you're asking people how much do you like this, then you're sort of you're making a bigger demand on the user, perhaps. Let's just skim it a little bit to get an overview. All right, so he's talking, it's a generalization. Here we go into content based. What do we actually want to learn about? If we're trying to make it more specific, let's see. And we definitely want to get an understanding of the cold start problem. explain why unary ratings are significantly different. Are there answers as well? No. So, all right, let's see. So unary ratings are significantly different because we are losing context or information on exactly how much they liked the particular product. And so, you know, or it might be that they've actually, we just know that they have rated it, maybe, but we don't know if they like it or if they dislike it or how much. So we might just know that they've interacted with this particular thing, but we don't know if it's positive or negative. Discuss cases in which content-based will not perform as well as rating-based collaborative filtering. To me, it seems like content-based recommendation will not be good if the features that we have are... It's very difficult to come up with exactly what features we want to have. And maybe it's difficult to collect them, and it's expensive to maybe have a human go through each movie and actually come up with the features. So, and it feels like ratings-based collaborative filtering will improve if we have a lot of data, because the model can implicitly learn each movie itself and each user. I don't know if this is right or wrong. I'm just thinking out loud. It would be cool to have answers for those. And then let's see, suppose you set up a system where a guided visual interface is used in order to determine a guided visual interface. What category of, I guess we missed that from, I don't know what system that is. I feel like we definitely want to read this chapter because we want to understand collaborative filtering a lot better and understand how we make the similarity metrics like cosine similarity and so on. And if one wants to go into a user-based or item-based approach, yeah, this is a good chapter, I feel like. Graph models. And chapter 3, I guess, as well, model based. So wait, the previous one was memory based, I guess, so it's a very simple one. And then here we actually decision regression trees, and maybe goes into neural networks. Example, using a neural network as a black box. So from my understanding right now, we're going to go chapter 2 and 3, maybe skip some of the sections here because they might not be that relevant. We might want to do this SVD approach as well. I don't think it should be that difficult to do it. And these content based, I don't think we're going to get into that much, but might be interesting to get in just an overview. And knowledge based, I think we will skip. Hybrid based might be interesting. And then we want to definitely know how to evaluate things. So that's chapter 7. Cool. And I don't think context sensitive is that important unless we build some project that actually is, and then you can learn about it at that point. But for now, I think we will skip those and go to this chapter 2. Go. Yeah, but I'll be right back. So it would be cool to also implement this here. Right now we have sort of one thing now is I don't know how to do this splitting of train val and test. So we might take a look at how to do that. So you could do either a content-based or collaborative filtering here. Exploratory data analysis. So this is kind of my idea, that we take each user and we just take a few of their observed ratings and we split it. Oh, maybe we can ask. Okay, so we're just splitting here. He splits just the ratings one, so we get some of the ratings on the test and some of the train. And then evaluate, we use MAE and MSE. This is pretty interesting, that the mean rating is higher for... This is quite noticeable on IMDb, for example. If you're looking at a comedy movie, it's usually a lot lower rated than... Interesting also. I mean, this is pretty interesting. So we have that men like action more. Let's see, romance. Yeah, romance is a lot more interesting to females. Comedy as well, a little bit. Maybe we can first make it to PyTorch Lightning. we need to do? We need to split it. So convert to Lightning code is what we wanted to do. I guess that's kind of what we've done now. We should also create a class Lightning data. And here we should set up all the stuff. And that's all we should need, I think. So in the load data, all that we're actually going to use is the DF ratings. This is for content based, I guess. We can still keep it, but we're not going to use it, I think. So if we now do, instead of doing this, we'll do data module. So we prepare the data and we have this self.dataset is equal to movie lens self.df ratings. So I guess we should be able to do dm.dataset.df ratings. Can you do this? I don't remember how you did this to check the I did not know you had to do that. I don't remember I had to do that, because I think this should be done like I don't know. Let's check it. So we my old code here. Prepare data, download it, and then we set it up. But here we only do this, and that's it. And then we initialize the trainer, and then we do trainer.fit on data module, and nothing is needed. So a bit confusing why. What did we do at the bottom? Because this is a bit confusing to me. So we did PL trainer, and then yeah, I mean, this is the exact same structure, so I guess it's because it needs to be run before, like, it's going to be done in the trainer or when we do trainer.fit, but we actually need it before. So, I mean, that might be how we can do it. I don't like that we get these errors and stuff. And, all right, we got an error as well. We should be able to remove these, I think, because we're going to do it in the actual data. And we are not going to be using this. Yeah, okay, this is correct. And then the Lightning module, we set up DF ratings, we send that in. And here we're going to do sort of a test and train. So we have that split. And we can remove this. And we should not do number of unique here. For some reason it's not. So we'll just do max. Okay, cool. So now we have that. We can now split it so that we have a test and train. And then we will see how we can make predictions. All right, the loss is definitely decreasing, but we need to have metrics for it to know that it works. And so we'll use this code as we introduce more topics. Once we learn the topics from this book here, we'll try to incorporate them, and maybe we can use like multiple different models and stuff like that. Here we're doing this, right? But we can maybe do other things as well. Maybe the matrix factorization with SVD would be one of the first approaches, I think. We could also check out sort of k-nearest neighbor and do simpler stuff, or memory based with cosine similarity. We'll see what we learn about, but I will take a break now. I'll go eat some lunch, go to the gym, and I'll be back in maybe 2 hours. And then we'll continue if you want to join. It'll probably be a couple of hours then. Is there anyone here, by the way? Or am I alone? I haven't seen any update in the chat for a while. Scale of 1 to 10, how much are you enjoying PyTorch Lightning? Let's see, I guess like I haven't, so I like it maybe 8 out of 10. Let's see, I guess like PyTorch Lightning is nice. I think it will it makes things a lot more convenient when scaling stuff. I mean, I made the first video is sort of why Lightning, so it's gonna be uploaded this week, but I like it. But all right, cool. Nice to know I'm not alone. But I'll take a break now, and then I'll be back in maybe 2 hours if you're gonna join, and we'll continue off from this understanding this neighborhood-based collaborative filtering and incorporating it into our code step by step. And we definitely need to add evaluation metrics, and then we need to do predictions, and we need to compare different types of algorithms. So we need to understand, I mean, we don't want to just jump into some complex neural network. We definitely want to understand matrix factorization with SVD, or maybe even some even simpler, just with cosine similarity, or even other things. So that's the idea, and then we'll scale our project. Can you suggest Lightning course? I have 10 series videos that I'll be releasing. Lightning is not that difficult to learn for the basics, at least, which is what I'll be going through. And I think after those, I mean, in total, the duration of all the videos is just like 100 minutes. So in 1.5 hours, I think you can learn Lightning to have a basic sense so that you can start using it. It's really just a simple wrapper. It's not like a completely new framework that you have to learn. Yeah, I mean, have you done the basics in PyTorch or done the basics in Lightning? Because I feel like if you know Lightning, then the difficulty is just understanding the research paper and their method rather than the framework. Okay. Yeah, but then I mean I feel like the difficulty is just trying to understand the research paper itself, and then how they actually did it and their method. And But all right, let's see. I don't know how long this stream was, but maybe it was a pretty short stream, about 2 hours maybe. Have you dug into the Lightning code? Is it a well-created wrapper? Well, I guess I haven't dug, like, there are many things that I don't understand, but I know how to use it, and it seems pretty nice so far. But, you know, if you look at the popularity of Lightning, then I think, and the number of the people that use it are serious people. So I think it's a good framework or a good wrapper. Text to image GAN, I think that would be probably like a diffusion model then. And I do want to get into that, but I have projects now. Cool. Welcome back, Anai. I was just saying I'm gonna take a break for a bit and then I'll be back. But we are gonna take a look at how to split the NADA evaluation matrix to this simple project and then add new algorithms. All right, thanks for joining, guys, and I'll see you later if you're gonna join. I'll be back in 2 hours. All right, take care. Love you all. Bye-bye.